Is more material being used than actually needed for this can and its fluid ounces? Let's see. And here is our equation. We want to find out the area. So you're going to use the area formula, which is 2 pi r squared plus 2 pi r times height. Now, you can't fill out this formula until you find out r and h. So, you're going to need to basically figure those two out. But what you first have to start off with is how much fluid is in the can. So you found that out, and it was 2.25 ounces. But you have to convert that into centimeters, which is going to be 66.540 centimeters cubed, because you're not using a fluid formula, you're using actual length. So the first thing you want to do is find the height equation. So you want to get h by itself. So you're going to set up 66.540 equals 2 pi r times 2 RH. So your first step is to divide 4 pi r squared, and you got 4 pi r squared from the 2 pi r times 2r, and that's going to leave you with 66.540 over 4 pi r squared equals h, which is your height equation. Now what do you want to do? You want to get r by itself. So you're going to take the original equation from up here and plug in your 66.540 over 4 pi r squared and put it into the equation. Now when you put it in for h, you substitute it in for h, you're going to find that you can take out that 2 and 2 of that, which you just have 2 left out of the 4. You can take out pi, and you can take out the r up here and 1 r right here, so you're still left with an r. So after you've done that, you have a equals 2 pi r squared plus 33.27, because you can take that 2 and divide it into that, and over r. Now you want to get r by itself. So take the derivative, move that r up here because you can't take the derivative with that denominator. It'll just be way easier if you put r up here, r to the -1, and start working it out. And you're going to end up, and your derivative is going to end up being 4 pi r times 2 minus 1 plus negative 33.27 over r squared, because you had to make that negative, minus 1 makes it -2, move it back to the denominator, and so set it equal to 0 because you're still trying to find r by itself, minus 4 pi r minus 4 pi r, multiply r squared on both sides, multiply r squared, and you're going to end up with negative 33.27 equals negative 4 pi r cubed. So you're going to, again trying to get r by itself, divide by 4 pi, you get 2.65 equals r cubed, cube it. You're going to end up with 1.38 for equals r. Now, you're not done with this. You have to plug r into your height equation. Now, when you plug r into your height equation, it's going to look like this. You're going to put that 1.38 where the r was, and it's going to equal 2.78. And go right here and plug in r and h into starting equation, which is your starting equation. Plug it in, and it's going to come out into 36.07 in your can. Now, if you're going to take the actual can and use a shoelace, a string, anything you want to see its length and height. You're going to use a shoelace because you have to take the shoelace and wrap it around the can. It's going to be 8.5 or 8.5. Height will be 2. And you're going to plug in your length and height into the starting equation. It's going to be 2 pi times 8.5. I accidentally put a little O there. squared plus 2 pi 8.5 times 2, which is 106.81 for the can. That's the can. That's your actual material being used, and that is how much is in the can. So the material being wasted here is 70.74 centimeters of material wasted. That's tin that doesn't need to be used. It's wasteful, obviously.